get this done right. And get our panda right. There we go. So imagine a scenario. Let me see if I get a straight line here. There we go. Yeah, scenario in which guy's sitting down here. He launches something upward with an initial velocity v. Let's make it go straight up and down. V initial. The time that it takes to go to the top is v initial over 10. And that'll take us to the time it takes to get to the top. Time for the top. Okay, so the time at the top. Let's say it's a 40. If V initial is 40, then it takes about 4 seconds to get to the top. If V initial is 30, it takes about 3 seconds to get to the top. If V initial is 26.2 meters per second, then the time it takes to get to the top is approximately 2.62 seconds. Then it takes another of that amount to get back to the bottom. So time to the top times 2 equals time of flight. Okay, so that's a good little shortcut to remember is V initial divided by 10 equals the time it takes to get to the top. So keeping that in mind, the height that it goes to, the height maximum, is equal to V initial squared over 2g. So V initial squared over 2g. So just plug in a number. If it's 20 meters per second, that quantity is squared, divided by 2g, which is 20. So 20 squared divided by 20, this one cancels with that, so it's 20 meters, because this is meters squared per second squared, and this is meters per second squared. Meters per second squared cancels meter here, yep, so we're left with 20 meters. Okay, so if it's not all these that handy, if V initial is 30, so it's 30 meters per second, that quantity squared, divided by 20 meters per second squared. That works out to be 900 meters squared per second squared, divided by 20 meters per second squared. The per second squared goes away, meters cancels with one of those, so we're left with meters. So 900 over 20 is 450. 45 meters. So that's 30 meters per second, takes about 3 seconds. So if something falls for 3 seconds, it goes 45 meters. Let's talk about that. So we'll just scroll up here and we'll draw a new picture. So we're going to draw our cliff and the drop. Okay, so we'll draw a line out here. Perfect. So if we're up here and we throw something off the cliff and it falls for a time of fall equals 3 seconds, then the height is going to be equal to 5t squared, right? So that's provided V initial is 0. So the height is always 5t squared if it falls. Height something falls is 5t squared. So if it falls for 1 second, let's t equals 1, then height is 5 meters. If t is 2, height is 2 squared is 4 times 5 is 20 meters. So if height is, or the time is 3, 3 squared is 9 times 5 is 45 meters. So in the first second it falls 5. In the second second it goes from 5 to 20, it falls 15. In the third second, the difference between these two is 25. Okay, et cetera, et cetera, et cetera. Okay? So here's another thing to think about. The height that it falls to, or the distance that it drops in the time, if you go back to your original, say your guy over here, he's throwing something up with an initial velocity of 50 meters per second. We know that the time it takes to get to the top is this V initial divided by 10. So 50 over 10 is 5 seconds. Well, then translate that into a drop, because if it takes 5 seconds to get up here, it takes 5 more seconds for it to fall down here. Okay. So 5 seconds for on the way up, 5 up, 5 down. So if it's a 5-second drop, 5t squared, 5 times 5 is 25 times 5 is 125 meters. So the height that it goes to is 125 meters. Now that height you can get from 2 different things. You can say 50 squared over 2g, or 20. 2,500 divided by 20. Okay. It's 125 meters. Same. All right. Hopefully that helps.